Alright, on this slide here, we're going to be looking at the major bones of the skull. Now, we're going to start from the front view of the skull here. And from the front view of the skull, you can see several prominent bones. The first one is the front bone right here that makes up your forehead. This is the frontal bone. Now, the frontal bone extends all the way back from this line here. This is the coronal suture. And the frontal bone goes all the way back and back underneath the eyelids. Now, still on the front side of the skull, you're going to see this bone right here. Okay, this is your cheekbone or zygomatic bone. Attached to this is now the zygomatic bone has another mate on the other side. These are two paired bones. The frontal bone is a singular bone. Just like this bone down here, the mandible or lower jaw. These two bones, the mandible and the frontal bone, do not have a mate, but the zygomatic bone or your cheekbones and the maxilla do have mates, left and right. Now, still on the front of the skull, you see these two bones right here. These are either nasal bones. Now, the rest of the nose is made up of cartilage that comes out, but these are the two parts right here that are actually paired, a right and a left nasal bone. From in here, from this view also, you can see this part right here. This bone that looks like the front end of a plow, that's called the vomer bone. Vomer actually means plow. From the side view of the skull, you can still make out the frontal bone. You can still see the coronal suture coming around here from the side. And everything to the front here is the frontal bone. And again, you can still make out the zygomatic bone. Now, this part right here is the zygomatic arch, which is made of both the zygomatic bone and this bone right here that you could see from this side view. You couldn't see this from the front. This bone right here is the temporal bone. You'll find this just on the temples of your skull. And just above those, you have paired bones, the parietal bone. The parietal bone goes all the way back from the occipital bone in the back, which you can barely make out back here, and the temporal bone, and extends all the way up to the middle of the skull, where you see this sagittal suture that runs back and forth and divides your skull into right and left halves. Now, from this side view, one of the most prominent features that you need to know is this roughened extension of the temporal bone. This is called the mastoid process. Now, the mastoid process is a nature landmark. You can reach back behind your ear and you actually feel a solid bump. And you can tell it's really close to the ear because right here is the opening that would take your ear canal, carry the nerves back into your brain. Now, the back view of the skull, you'll see the suture that goes across and down. This is the lambdoid suture, and this separates the parietal bones from the occipital bone. Okay, this occipital bone is the back part of your skull. Now, there's several things you need to remember about the occipital bone, several notable features. First of all, here's this big bump right back here, which is a point of attachment for many of your back muscles. The muscles pull on here and pull your head upright. Now, from this view also, you can see right down here this huge opening. This opening is called the foramen magnum. This is the opening through which the spinal cord passes through and becomes continuous, with the vertebrae. And you have these two rounded portions right down here that are going to connect to the atlas bone, first part of the vertebral column, and this is going to form a pivot point where these bones are going to move back and forth. They form the allanto-occipital joint. Now, on this model here, this is a plastic model, you see a little structure right down here. This is the styloid process. On most natural bone skeletons, these processes are lost, because they break off very easily, but on a plastic model like this, you can see this. Again, this is another point of many muscle attachments here that control like your throat. Now, two other bones that you have on your chart here that you need to know are very hard to see from the outside. We're going to try and show them to you here. The first one is the ethmoid bone. From the inside you can see it here. That's going to make up part of the eye orbit, the inside portion in here. That's the ethmoid. You'll also have the sphenoid bone. Now the sphenoid bone is this one here that kind of looks like a moth or a bat, right through here. Okay, and again, this is going to make up the lateral walls of the eye orbit and part of the lowest part of the skull. Now, in the sphenoid bone, you have this little part here called the coelica tunica. This part is where the pituitary gland rests, so it's well protected because that is considered the master gland, which we'll study more when we do the endocrine glands. Finally, as part of the skull, really didn't know where else to put this bone. It's a very, very small bone, as you can see here. As we zoom out to give you an idea of the size, it's really quite small. This bone is called the hyoid bone. The hyoid bone is the one that I jokingly call the orphan bone, because this is the only bone in your body that does not form a joint with another, form a connection with another bone anyplace else in the body. This one sits underneath your chin, back of your throat. This is the one that a forensic scientist, if they see that they suspect a murder victim has been strangled, this bone, being very, very small and delicate, will be crushed. An idea about where the hyoid bone sits. It's going to sit mid-anterior, right about in here. Now, it's going to be attached to, by ligaments, to these styloid processes that I showed you earlier. Again, these styloid processes are generally broken off in a natural bone skeleton, but in a plastic model, you can see where they would sit. And in this position right here, you can easily see how this bone could be broken or crushed if a murder victim is being strangled. What you see here is a typical cervical vertebrae. Remember, there are 7 of these vertebrae, and they make up the neck. Now, there are certain characteristics that you'll need to look for when you identify these to tell you that it is a cervical vertebrae. That's what we're going to be looking at right now. Cervical vertebrae traditionally have a triangular shaped opening right here. This opening, which is going to be triangular shaped in the typical cervical vertebrae, is called the vertebral foramen. This is the opening through which the nerves are going to pass through, as part of the spinal cord. Now, the other features that you'll need to look at from this view, cervical vertebrae are going to have right here, this projection coming off is called the spinous process. The typical cervical vertebrae has a fork at the end of the process. This is called a bifid spinous process, meaning two-forked. All right, now the third feature that's going to make it real characteristic that should be able to help you identify it as a cervical vertebrae are these openings right here. This opening right there is very typical of cervical vertebrae. This is called the foramen of the transverse process. This part coming off right here is the transverse process, and there is an opening through here. Now, you won't see this on other vertebrae. This is found only in cervical vertebrae because this is the opening through which the blood vessels are going to pass through, supply blood to the brain. With cervical vertebrae, you just saw the typical cervical vertebrae, but there are two vertebrae of the neck that are specially structured for their functions. Remember, structure relates to function. Now, these two bones are going to be responsible for you nodding your head up and down like agreeing with somebody, saying yes, or pivoting your head back and forth, signifying no. The structure of these two bones are going to allow you to do those two actions. Vertebrae C1 is also called the atlas. That name comes from ancient Greek mythology, In ancient Greek mythology, they believe the demigod Atlas rested the earth on top of his shoulders. Now, here, this is called the Atlas because your head rests on top of these two facets. These two facets fit into the occipital condyles of the skull. So, sitting on here, your head will pivot up and down, signifying yes, you agree with somebody. One unique feature about the Atlas is the fact that it doesn't have a center portion like the other vertebrae have. That center portion or body is missing on C1 or the Atlas. Now, where did it go? It looks like it was here. This is vertebrae C2. Now, this is called the axis. Now, the way they fit together, this is C2, this is C1. They would fit like this. So if you're going to shake your head no, your head's going to pivot around this part here, which is called the dens. Now when the dens is there are ligaments that are going across, holding this together. So what happens then when you shake your head no, you're just pivoting back and forth like this. Yes is from here. Top of your head goes up and down, and no. Now C2, what most evolutionary biologists think happened, this dens right here was the body of C1. Just in order to allow that function to turn your head back and forth, it became attached to C2.
All right, we are going to go over all of the muscles on the face and neck in this video. All right, the masseter is located right here. It's going to be our primary chewing muscle, so it moves the jaw up and down. Our buccinator is a deep muscle located right here, and this is the blowing muscle. So blowing like into a trumpet or whistling would activate that muscle. You have your zygomaticus muscles here, major and minor. They connect to our zygomatic arch on the skull. We have two circular muscles on our face. The orbicularis oculi is around the eye, and that's our winking muscle. So obviously that opens and closes the eye. We also have the orbicularis oris, which is another circular muscle located around the lips. So that is sometimes called the kissing muscle. Okay, our next muscle is going to be the temporalis muscle. If you can feel your temples and you chew, you can feel it working. So this is an accessory chewing muscle. All right, we have some muscles on the neck here. Sternocleidomastoid is located right here. This is a two-headed muscle, and you have two of them, so you have one on either side of your neck. It connects right to the mastoid process of your skull. You can feel it right behind your ear. So your sternocleidomastoid would connect right there. If you contract both of them, it will bow your head. That's why sometimes these are called the praying muscles. If you only contract one of them, it's going to tilt your head and rotate it. The next one is going to be our platysma muscle. This is a sheet-like muscle located right here, and its job is to kind of turn your lips downward. Our next sets, we have our scalene muscles, and this is a set of 3 muscles, and their job is to flex the neck forward. And the opposite of that would be our splenius muscle, which is located just below the trapezius muscle here, this large muscle in the back. And the splenius muscle extends your neck. So the scalene muscles will flex them, the splenius muscles will then extend them.